We're competing in the Swarmathon competition sponsored by NASA and the University of New Mexico.
When we send a rover out to Mars, it's a $700 million rover, where if we were to do this with Swarm Robotics, you can have all the other rovers compensate.
The NASA Swarmathon is really exciting because some of our ideas could potentially be used in the future for trips to Mars or to establish a permanent base on the moon.
The goals of the competition are to simulate autonomous rovers to collect resources prior to having the first man land on Mars, so they will have resources ready and available for them.
For the next decade or so, they're going to try to send actual astronauts to Mars and stay there for a little bit and come back to Earth. Your generation of people is going to be the astronauts and the engineers and the technicians that put this all together and make a journey to Mars. If you want to be part of that, you guys are in a great position to do that.
We start with 3 rovers, all operating identical code. There's no human interaction. They are working autonomously.
The camera on the front is meant to detect these April tags, so they're going to be scattered all over the floor.
Whoever gathers the most wins.
So our students have really stepped up their game to start learning some of the new programming and the language and just the physical interconnections that they're never really allowed to do in their programming courses. The computer science students have always, worked in this virtual box and done projects that really don't make anything move or go left or go right or target acquisition or any of these things. So providing this new kind of connection between the physical and the virtual world has been amazing for our students.
So we did some testing with the class where we kind of had them, each as teams, develop their own algorithms, tested them in simulation, and then we iterated upon that process, but then we went to testing them on physical platforms.
One of my favorite parts of the Swarmathon was that it was project-based learning. By this I mean that we were using the same programming concepts that we were learning in our artificial intelligence course, such as machine learning and computer vision, in which we actually ended up using in our code.
Hello, my name is David Wu, and what surprised me most about this project is how far people are willing to go in order to work on it. What I'm most proud of is everyone else who just comes in every day during spring break, during the weekends, during their own time off, just to work on this project.
The most surprising thing for me is how the team work together in a new thing. It's so hard to get it started. So the most proud of this project is when our team got a goal and we want okay, we got this algorithm or idea to do. All of us work really hard together. We sacrifice a lot of extra hours in this. We work in somebody's teammate's house and try so hard to get everything work. So I feel so proud being in these teams to witness everything's happen, and we kind of finished our work.
So our biggest challenge right now is making sure that the search algorithm is functioning the way that we expect it to.
It doesn't pick up the angle.
Is it found any?
X and Y positions are off. We have to fix that.
If he doesn't know where he is, there's no point in trying to give him directions since it'll all be wrong anyways.
I'm frustrated, I'm lost.
Team effort of pain.
Yes.
Trying to get them off.
Learning ROS is a huge undertaking. It's not easy. Writing code was difficult.
And understanding the creating code, because the comments were there, but they weren't so clear as into what exactly. So trying to figure out the algorithm behind was also kind of a challenge.
If we won this competition, it would mean so much for me and my team. I'd probably cry, and I haven't done that in 10 years because we've all worked so hard. We've gotten really, really close. Basically teaching ourselves how to do this from scratch, and between that and coming up with the money to send us all to Florida to just go see them compete, I mean, it'll make it all worth it.
There were a lot of challenges during this competition, but it was rewarding to see the end result. Well, in conclusion, we had a lot of challenges and a lot of good results that came out of this. We learned a lot more about ROS and how ROS is run, pretty much how our codes were written, different codes, and how ROS got to help us apply all of that to our swarm.
Actually, this was my first time doing anything related to robots, and it was actually great because I learned a lot of things. I learned how to program, and I learned many programming techniques that I would not have learned inside class. I feel like I'm a better programmer now that I've done this competition.
Because it gave me the idea of how to work in a team, how to communicate, how to attack a code, and how to analyze coding regardless if I know the application or not. So it gave me a better understanding of what my field will come with.
I think this is a great thing, especially for us, since we are an underserved community. Like, it gives us pride to be part of this program because it's NASA and everyone wants to be part of it. It's challenging, it was challenging, but the learning process was really what matters at the end of the day.